Our Tennessee State Standard today is to perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. Use scientific notation and choose units of appropriate size for measurements of very large or very small quantities. For example, use millimeters per year for seafloor spreading. Interpret scientific notation that has been generated by technology. Your lesson objective today, I am learning to use the laws of exponents to multiply and divide numbers written in scientific notation. So you'll need to pause the video and write that down. All right, when we multiply with scientific notation, we have 4 times 10 to the third times 2.1 times 10 to the fourth. We want to rewrite and group the numbers together and the powers together. So what property tells us that we can move things around to make it easier for us, that we can put our numbers together? That would be commutative. So we say 4 times 2.1 times 10, and we know when we multiply powers that have the same base, we add their exponents. So 10 to the 3 plus 4. Now, 4 times 2.1 is 8.4 times 10, and 3 plus 4 is 7. So we multiply the numbers to get the first factor, and then we add the exponents to get the power of 10. All right, so first thing, we rewrite it and group the numbers together. So 1.4 times 2.0, can I leave that as 2? I can, to make it easier to multiply, times 10, and when we multiply powers with the same base, we add the exponents, so 10 to the 2 plus 6. So 2 times 4 is 8, 2 times 1 is 2. That would give us 2.8 times 10 to the 8th power. And if they wanted us to change that to standard form, like we learned yesterday, we would just move our decimal to the right 8 times. But we're just going to leave them in scientific notation today, unless the problem calls for it to be otherwise. All right, number 2. We can say 2 times 2.3, put our first factors together, times 10 to the negative 3 plus negative 2. Negative 3 minus 2 is the same thing as negative 3 plus negative 2. So 2 times 2.3 is 4.6 times 10 to the negative 5. And when we deal with scientific notation, we can leave the negative exponents there. Solve the following problem. Well, let's put our numbers and our powers of 10 together. So 4 times 3.2 times 10 to the 2 plus 2. Well, 4 times 2 is 8, and 4 times 3 is 12. 1 decimal place here, 1 decimal place here, times 10 to the 4th. Think about what you notice about this product that's different from our previous problem. So tomorrow you'll get a chance to talk about this in your groups. But think about how we learn to write things to convert from standard form to scientific notation. What needs to be done to make this problem, or to write this problem in scientific notation? So I want you to think about that. And we'll work that problem tomorrow during class. All right. We're going to go ahead and work these because I don't want to take up all your class time tomorrow. So I know that I have 9.1 times 5 times 10 to the 7 plus 4. So 5 times 1 is 5. 5 times 9 is 45 times 10 to the 11th. But we'll wait till tomorrow after you've had a chance to talk. to take this problem further. All right, rewrite and group 2.1 times 9 times 10 to the negative 3 plus negative 4. So 9 times 1 is 9. 9 times 2 is 18 times 10 to the negative 7. And we'll look at that problem tomorrow too and finish working it. All right, division in scientific notation. We once again are going to rewrite and group our numbers together and our powers together. So our numbers, 8.4 divided by 2. And if I do that calculation, 2 goes into 4 2 times, 2 goes into 8 4 times. I get 4.2. And we know that when we divide powers with the same base, we subtract the exponents. So 4.2 times 10 to the 6 minus 3, and we get 4.2 times 10 to the third power, expressed in scientific notation. All right, so I'm going to group these together. So 3 goes into 9 3 times, and 3 goes into 6 2 times 10 to the 8 minus 2. So that would be 3.2 times 10 to the 6. 6.8 divided by 2. 2 goes into 6 3 times. 2 goes into 8 4 times. Times 10 to the negative 11 minus 8. And that would give us 3.4 times 10 to the negative 19. And that's definitely one I want to write in scientific notation instead of standard notation. All right. Well, I know that 2 divided by 4 is 1/2, and I know that 1/2 is equal to 5/10 times 10 to the 5 minus 2, which equals 5/10 times 10 to the third power. Now, what do you notice about this quotient that's different from the previous problems? And what needs to be done so that it can be transformed or converted into scientific notation? And I just want you to think about this, and we will discuss it tomorrow. All right, 1/4 of a dollar is 0.25 times 10 to the negative 4 minus negative 7. So 0.25 times 10, and that actually says negative 4 minus negative says plus. Negative 4 plus 7 is positive 3. And we'll finish working that tomorrow after we've had our group discussion. 2 divided by 5, 2/5 is actually 4/10 times 10 to the 7 minus negative 3. Minus negative really means plus. So 4/10 times 10 to the 10th. And we will finish that one tomorrow as well. So, to summarize, when multiplying in scientific notation, what do we do with coefficients or the first factors? What do we do with the exponents? What happens if our product isn't in scientific notation, and how will we know? When dividing in scientific notation, what do you do with the coefficients? What do you do with the exponents? And what happens if our quotient isn't in scientific notation? How will we know? We'll discuss all of those tomorrow, but I want you to be thinking about all those before tomorrow. All right, the distance from Earth to the imaginary planet Med is 1.7 times 10 to the 7th miles. If a spaceship is capable of traveling 1,420 miles per hour, how many days will it take the spaceship to reach the planet Med? Round your answer to the nearest day. Okay, well, first of all, I want to write this 1,420 in scientific notation. So 1,420 would actually be 1.42, step one, rewrite it with the decimal after the first natural number. Step two, times 10, and then we've moved that decimal from here to here, which means we've moved it 3 places, and our original problem was greater than 1, so we leave that as positive. So this is how many miles per hour we can travel, and this is how many miles we have to travel. So we're going to do this as a division problem. 1.7 times 10 to the 7th divided by 1.42 times 10 to the 3rd. And we're going to group these together. So we know times 10 to the 7 minus 3. We're going to use a calculator on this one because I don't want to do a lot of long division. I don't want you focusing on a lot of long division. So 1.7 divided by 1.42, we're going to round to 1.197. So this would be 1.197 times 10 to the 4th. So that's how many hours it's going to take us. 1.197 times 10 to the 4th. I'm going to rewrite that in standard form. So 1.197 times 10 to the 4th, which means I'm going to move this 1, 2, 3, 4, gives us that many hours that it's going to take us. But it really wants us to tell to the nearest day. So we're going to have to divide by how many hours in a day? 24. So we're also going to do this. 11,970 divided by 24 equals 498.75. But this says round your answer to the nearest day, which means 499 days. And that is the end of our lesson today. Be ready to discuss all the different rules that we talked about today.